On a December night in 2021, a woman in Wingo, Kentucky, woke to the feeling of her house seeming to breathe, then the sound of breaking glass. Before she could even stand, she was pulled straight through her bedroom window by a tornado she never saw coming and thrown a few hundred feet into the dark. Her town sits nowhere near the old tornado alley, and that is exactly the problem. That night became the deadliest December tornado outbreak ever recorded, with at least 66 tornadoes and around 90 people killed. America's tornado threat is migrating east, off the open Great Plains, and onto far more crowded, far more vulnerable ground. By the end of this video, you will understand where the new danger zone is, what is driving it there, and why these storms are now so much more likely to kill. The United States is the most tornado-prone country on the planet, and it is not close. In an average year, this one nation records around 3/4 of every tornado documented anywhere on Earth, somewhere between 1,100 and 1,200 confirmed twisters, more than every other country on the globe combined. For as long as anyone watching this has been alive, the center of that violence has sat in one place: the Great Plains, the wide corridor running through Texas, Oklahoma, Kansas, and Nebraska that we have always called Tornado Alley. That name has felt as permanent as the rivers and the state lines. It is not. The single most important fact in American severe weather right now is that Tornado Alley is moving, and it is moving east. This is not a forecast or a model of some distant future. It is a measured trend that has already been unfolding for decades. When scientists plot tornado activity across the country over the last 40 to 50 years, the Great Plains, the supposed capital of tornadoes on Earth, show a clear decline. At the same time, the Midwest, the Mid-South, and the Southeast show a clear, robust increase. The tornadoes are not vanishing. They are relocating, sliding out of the open plains and into a different part of the country entirely. Here's the part that makes this far more than a curiosity. The total number of tornadoes the United States gets each year has stayed roughly the same. The national count is essentially flat. So a stable number at the top is hiding an enormous reshuffling underneath it. Nearly every tornado the plains have lost has reappeared somewhere to the east. And the places gaining that risk are not empty. They are more crowded, more vulnerable, and far more dangerous to be caught in when a tornado actually comes. That is the entire story in one sentence. The threat is moving off the open farmland and onto the worst possible ground. Let me show you exactly how we know that and why it matters so much. The scientist most responsible for putting hard numbers on this is Victor Gensini, an atmospheric researcher at Northern Illinois University. He did not stumble onto the idea in a classroom. He noticed it out in the field, after several seasons of storm chasing across the Great Plains during years when the tornadoes simply did not show up the way they were supposed to. He found himself standing in the place that is meant to be the most tornado-prone spot on Earth, watching very little happen, and he began to wonder whether something had genuinely changed. So he went back and ran the data. In 2018, Gensini and a colleague named Harold Brooks published a study tracking tornado reports and tornado-favorable conditions from 1979 through 2017. The results were hard to argue with. They found statistically significant decreases in tornado activity across portions of Texas, Oklahoma, and northeast Colorado, the western core of the old alley. And they found significant increases across Mississippi, Alabama, Arkansas, Missouri, Illinois, Indiana, Tennessee, and Kentucky. When you look at a map of those trends, or when you look at the risk over time at one specific city, the pattern becomes impossible to miss. In Gensini's own words, this is definitely a trend, and it is real. The scale of the shift is large. The zone of peak tornado conditions has migrated something like 500 miles east of where it used to sit, and a new belt of danger across the lower Mississippi Valley, a region some now call Dixie Alley, is catching up fast. And the trend is not slowing down. Gensini has said the eastern increase is not only continuing but happening at a faster rate. In 2025, Illinois, not Oklahoma, not Kansas, but Illinois led the entire country in tornado count for the year. Now, this does not mean the Great Plains are finished. Kansas, Oklahoma, and Texas are still the single most tornado-frequent region in the United States, and they will be for a long time. The point is narrower and more unsettling than that. The plains are trending down, the east is trending up, and the gap between them is closing. The real question is why. To understand why the map is changing, you first have to understand why the map exists at all. The reason the United States gets the overwhelming majority of the world's tornadoes comes down to a quirk of geography that no other continent shares. North America runs unbroken from the Arctic all the way to the tropics, with no major mountain range crossing it from east to west. Europe has the Alps. Asia has the Himalayas. North America has nothing across the middle to stop air from the far north and air from the far south from slamming directly into one another. That open middle becomes a collision zone for three completely different kinds of air. Warm, moist air pushes up from the Gulf of Mexico. Cold, dry air pours down out of Canada. And warm, dry air drifts in off the deserts of the Southwest. When those three air masses meet over the central United States, the atmosphere becomes extraordinarily unstable, and instability is the raw fuel of every thunderstorm and every tornado on Earth. But instability alone is not enough. Building a tornado takes four ingredients working together at the same moment. The first is moisture. The second is that instability, warm air, that wants to rise on its own and pile up into tall storm clouds. The third is lift, which is some mechanism, like a weather front, that shoves that air upward fast enough to fire off real thunderstorms instead of harmless fair weather clouds. And the fourth ingredient is the one that separates an ordinary storm from a tornado factory: wind shear. Wind shear is the change in wind speed and direction as you climb up through the atmosphere. It is what lets a storm organize, stay alive, and begin to rotate, because it tilts the storm over and separates the rising updraft from the falling rain and downdraft. Without shear, the rain falls straight back down through the updraft, chokes it off, and the storm collapses on itself. With shear, the engine keeps running. Hold on to those four ingredients, because the eastward shift is really a story about how one of them is being quietly dragged across the country. Scientists believe the key to this entire eastward shift may come down to a single atmospheric feature with a deceptively simple name. They call it the cap. The cap is a layer of hot, dry air that parks itself a few thousand feet up, sitting directly on top of the warm, humid air near the ground. Think of it as a lid clamped down over a pot. Underneath that lid, the warm, moist Gulf air wants desperately to rise, but the cap holds it down and refuses to let storms break out. For a while, that lid actually suppresses everything. The energy just sits there and builds. It is exactly like slowly heating a covered pot of water on a stove. The heat does not escape. It accumulates, and the pressure underneath keeps climbing. Most days, the cap wins, and you get nothing but hazy, humid skies. But when the air trapped underneath finally gets hot enough and buoyant enough, an updraft punches straight through the lid, and when it breaks through after hours of stored up energy, the release is explosive. That sudden, violent vertical surge is what produces supercells, the rotating, long-lived thunderstorms that spawn the strongest and deadliest tornadoes there are. So the cap acts as a kind of gatekeeper, too strong, and nothing forms at all, just strong enough, and it filters out the weak storms while loading the deck for the monsters. That balance, how strong the cap is, and where it sits, turns out to be enormously sensitive to the climate around it. And that is the hinge of this whole story. Because the climate on the western side of Tornado Alley and the climate on the eastern side are now changing in opposite directions, the cap is behaving differently in the two regions. In the west, it is becoming a wall. In the east, it is becoming a launch pad. That single difference is quietly redrawing the tornado map of the United States, and it is worth walking through exactly how it works. Start in the west, in the traditional core of Tornado Alley. The American Southwest is getting hotter and drier as the climate warms, and that hotter, drier air strengthens the cap over places like West Texas. A stronger cap is a heavier lid. It builds a dome of hot, dry, high-pressure air over the western part of the country that drains the atmosphere of the energy storms need and slams the door on tornado development. The very ingredients that used to come together over the plains now get suppressed before they can ignite. That is why the data show tornado activity falling across Texas and Oklahoma. The lid out west is simply winning more often than it used to. Now go east, and the story flips completely. The Gulf of Mexico has been warming, with water temperatures up on the order of 1 to 2 degrees on average, and a warmer Gulf throws far more water vapor into the air above the Mid-South and the Southeast. That surge of moisture and instability is rocket fuel. It hands the atmosphere over places like Memphis and across Mississippi, Alabama, and Tennessee. Enough raw energy to punch clean through even a strong cap and erupt into supercells. So the West loses its storms to a strengthening lid, while the East gains the firepower to blow the lid off. When you look at the numbers in the Mid-South, you start to see the frequency of tornadoes and of strong tornadoes specifically climbing. The danger zone slides hundreds of miles toward the rising sun, landing on a part of the country that historically never saw anything like this volume of violent weather. It is important to be honest about what scientists can and cannot say here. Gensini and others are careful on exactly this point. As he puts it, there is clearly a climate change signal in the data, but what precisely is causing the shift is still, in his words, an open question. The eastward trend itself is solid and thoroughly documented. The mechanism behind it is extremely consistent with what a warming climate would predict, without yet being something anyone can prove beyond all doubt. What is not in doubt is where the tornadoes are landing now. And that is exactly where this story turns genuinely dangerous. The shift would matter far less if tornadoes behave the same way everywhere. They do not. The regions now gaining tornado risk are precisely the regions where tornadoes are most likely to kill you. And that overlap is what turns a geography lesson into a public safety emergency. If you map where tornadoes are most frequent, you get Kansas, Oklahoma, and Texas. But if you map where tornadoes most often turn fatal, you get a different list entirely: Alabama, Mississippi, Georgia, Tennessee, and Arkansas. The storms are moving straight toward the zone where the death map already lives. There are concrete reasons southern and mid-south tornadoes are so much more lethal, and the first one is raw speed. Out on the open plains, you can sometimes sit in a field and watch a storm crawl past at 5 miles an hour, slow enough to photograph and calmly drive away from. That is not how it works once these storms set up farther east. Driven by a stronger jet stream, tornado-producing storms in the Mid-South can race across the ground at 50, 60, even 70 miles an hour. A faster tornado gives people far less time to react after a warning goes out, and it stays on the ground over longer distances, carving longer and longer damage paths through everything in its way. The second problem is when these storms strike. In the classic alley, tornadoes follow a fairly predictable rhythm, mostly in spring and early summer, and mostly in the afternoon and early evening, when people are awake and the sky is bright enough to see a funnel coming from miles off. In the southeast, that comforting rhythm largely disappears. Because the Gulf keeps moisture flowing reliably all year long and around the clock, there is very little tornado season and very little tornado time of day. A violent tornado can come in any month of the year, and it can come in the dead of night. That single fact, the loss of daylight and the loss of warning that comes with it, is the deadliest part of all, and it deserves its own close look. Nighttime tornadoes are roughly twice as deadly as the ones that strike during the day, and the Southeast gets far more of them than anywhere else in the country. The numbers behind this are stark. One landmark study examined tens of thousands of tornadoes over more than half a century, and found that while only about 27% of tornadoes happen at night, those nighttime storms cause nearly 40% of all tornado deaths. Put another way, about 1 in every 20 nighttime tornadoes turns deadly, compared with only about 1 in 50 during the day. And the South is exactly where the night tornadoes cluster. In Tennessee, nearly half of all tornadoes happen after dark. In Arkansas and Kentucky, it is more than 4 in every 10. The reason is brutally simple. At night, people are asleep. They do not hear the warnings, they cannot see the sky, and a tornado that would be visible from miles away in daylight becomes effectively invisible until it is right on top of the house. By the time you hear it, it is already there. The danger does not stop with the darkness. The Southeast is also full of the kind of housing that tornadoes destroy most easily. Manufactured homes, what most people call mobile homes, are far more common across the South than in other parts of the country, partly because the high water table makes basements difficult to build. That matters enormously, because manufactured homes account for nearly half of all tornado deaths in the United States, and the risk of dying in one during a tornado is roughly 15 to 20 times higher than in a sturdy, permanent house. Layer on the terrain itself, the trees and rolling hills across much of the south that hide an approaching tornado and choke off escape routes, and you get a region where storms arrive faster, hit harder, come at night, and find people in the least protective shelter available. Every one of those factors is stacking up in the same place the tornadoes are now moving. And we have already seen, in painful detail, what happens when they all come together on a single night. There is one more factor at work here that has nothing to do with weather, and it may be the most important of all. The classic image of a tornado is one spinning across an empty field, with a single farmhouse off in the distance. That image is going out of date. As the danger zone slides east, tornadoes are increasingly crossing not open prairie, but towns, subdivisions, and far denser populations. More people and more buildings in the path simply means more chances for a tornado to hit something or someone. Researchers studying this call it rising impact potential, and it explains how the disaster toll can keep climbing even when the raw number of tornadoes does not. The deck is being stacked against these communities from two directions at once. The storms themselves are getting more dangerous, and there are more people standing directly in front of them. You can watch every one of these threads converge in a single event. On the night of December 10th into the 11th, 2021, a series of storms tore across the Midwest, the Mid-South, and the Ohio Valley and spawned at least 66 tornadoes. It became the deadliest December tornado outbreak ever recorded, killing around 90 people across 5 states, 76 of them in Kentucky alone. The hardest hit town, Mayfield, Kentucky, took a direct strike from a tornado rated EF4, nearly the strongest category there is, with winds estimated near 190 miles an hour, and it stayed on the ground for roughly 166 miles. One of the survivors was a woman named Heather Chambers, who lived in Wingo, Kentucky, a community that sits nowhere near the old tornado alley, but squarely inside the new rising risk zone. She has described waking that night to the strange feeling of the house seeming to take a breath and let it out, and then the sound of glass shattering. Before she could even get to her feet, she was pulled straight through a window. She came to rest a few hundred feet from her home in total darkness, buried under piles of debris, found alive only because a neighbor managed to dig her out. Her tornado was eastern. It came well after midnight, and it was invisible until it already had her. In one woman's story, on one December night, you can see everything this shift is bringing to millions of people who never signed up for it. The encouraging part of all this is that these storms, as terrifying as they are largely survivable if you prepare for them ahead of time. The experts who study tornado deaths are remarkably consistent about what actually keeps people alive, and the advice is simple enough to act on tonight. The first rule is the bluntest one. Do not be in a vehicle. If a tornado is bearing down and you are in a car, you are very likely to become a casualty. A vehicle is one of the worst places you can possibly be. What protects you is structure and distance. Get to the lowest floor you can reach, get into a small interior room, and put as many walls between yourself and the outside as possible. A small interior room is better than a large one, and you want to stay well away from windows because flying glass and debris are what injure and kill most people. Even the strongest tornadoes are very unlikely to take your life if you put enough walls between yourself and the storm and get down low. Some people in these high-risk areas have gone further, installing underground shelters or reinforced concrete safe rooms, and after the Kentucky outbreak, there were accounts of people who survived inside heavy concrete structures, while the houses all around them were torn to pieces. The single most valuable thing you can do, though, is the thing Heather Chambers learned the hardest way possible. Take the threat seriously before it ever arrives. She now starts preparing days ahead, the moment she hears a storm might be coming, rather than assuming it will pass her by like it always used to. That shift in mindset, from believing it probably will not happen to you, to planning as though it could happen tonight, may be the most important adaptation of all, especially for the millions of people across the Mid-South and Southeast who never used to think of themselves as living in tornado country. You should also know the difference between a watch, which means conditions are right for tornadoes to form, and a warning, which means one has been spotted or shows up on radar, and you need to be in your safe place immediately. Tornado Alley has held still for as long as we have had a name for it, and now it is sliding toward a new set of doorsteps. The storms are moving. The smartest thing any of us can do is stop assuming the map will keep us safe and start getting ready for the ground it is moving onto.